Hey guys, and welcome back to RealPrac. Today we're going to be learning about the Stirling Engine. But first, let me enlighten you on what it actually is. When I take this can, basically a couple of soda cans that's been set up in a way that once it's heated up enough, it spins finally on its own. So for this prep today guys, we're going to need a fair few things. So we're going to need a drill, you're also going to need a screwdriver, you're going to want some needle nose pliers. These are electrical terminal blocks on it. They come in, these things here, you get them from any electrical store really, and you're going to want some wire that's easy to bend and it's going to keep it shape. Balloon, bulbs with a large washer, fuse wire, 2 empty cans, old CD, and something to mount it onto the terminal block here. I've used a bit of wooden dowel, just epoxied it on and then epoxied on the metal dowel onto here. Steel wool, scissors, but if you have tin snips, use them. So for the first can guys, all you have to do is just cut a nice hole out the top here and try and keep it as clean as possible so you're not going to cut yourself on it. Mine's actually really jagged and sharp, so I'm probably going to cut myself. That's all you have to do for the first can. For the second can, you're going to also cut out the top, but you're also going to cut out that bottom base part here, and you also want to cut a nice circle in here so you can fit your fingers through and tweak your engine, I guess. And you're also going to want to drill 2 holes directly opposite to each other. I don't know if you can see that on the camera. Just to fit your wire through. With your steel wool, guys, what you're going to do is when it comes in your packet, it usually comes in sort of a sheet type setup. So what you're going to do is probably get a straw and wrap your steel wool relatively loosely around the straw. So until you get a nice size that's going to fit inside your first can relatively well. You want to fit in there pretty well. And what you want the straw in there for is so you can poke this wire here, so you can poke it straight through the middle of the steel wool. For the wire, just do a nice bend around here so it stops it from pulling through. The top, just do a nice hook, then you're going to tie on your fishing line. Try to have excess line because you're going to cut it off anyway at the end, so it's going to make life easier. So just you know, a 30 centimetre line if you can. Now the wire is probably going to be the hardest part of this prac here today. Now what you want to do is you're going to get your wire and you're going to do a series of bends here. It's kind of hard to see, I guess. At the start here, it's going to bend down, then run for a little bit to fit the terminal block on, then bend back up. And then it's going to come bend out with a 90 degree delay here. And this bend you're going to want a fair bit longer, so you can fit on another metal dowel. Kick on the dowels, there are electrical blocks, and then you're going to do the same as the first bend for at the end. You're going to want to spin relatively smoothly, so just spend some time tweaking it. Don't get too caught up in it, it's not for NASA or anything. And this is what's going to fit through the top of your can. And the last part we're going to have to set up is this balloon and bolt here. So for our balloon, you want to cut it off so it's just basically an elastic sheet. And your bolt, which is going to go through the centre, that's where that little bubble part is. And you're going to poke a hole in there and push your bolt through there. And you're also going to want to drill a hole through the centre of the bolt. It doesn't have to be dead centre, as you can see mine's a bit off with the hole. And you're also going to want, just with a bit of extra tin from your can, you're going to want to glue it over and poke a little hole, because you want this hole to be as small as possible because you don't want air leaking into your, I guess, your cylinder chamber. And you're going to want 2 washers to stop the bolt pulling through basically. You're just going to get the nut, screw it on with your fuse wire or just really small wire. You're going to bend it around so it fits around the thread of the screw. and you're probably going to want to leave a lot of excess wire here. So to assemble your kit together, what you're going to do is you're going to grab that can that you only cut the top out of, and you're going to grab the steel wool setup we got, and you're just going to shove it in here. And the way you know you've got your can in there properly is when you can lift it up and down freely, and it folds freely. Now after you've managed to get your steel wool set up inside the bottom can, what you're going to have to do is you're going to have to get your bolt with the balloon set up. And with a fishing line, you're going to poke it through that hole that you drilled through the bolt. And then you're going to fold the balloon over the edge of the can and hold it in place with the elastic band. So next up, you're going to grab this line that you got almost perfect for NASA, and you're going to poke it through. It's a bit tricky, you're going to have to cut off a bit of a wire, but you're going to have to try and get it through both ends of the can. Next, you're going to get your flywheel, which is just your CD, and it doesn't really matter what end, whichever end you prefer, and you're going to screw this into place on top of your can. You're also going to get another electrical block just to secure it on the end, so on the end it's just... Now you're going to bring both the cans together, push it down a little bit if you can, try not to break your top can, and now you've got the fun part of hooking up these wires. So you see these two wires in the back here, they go to the two outside ones, and your fishing line is going to hook up to the middle one.
The Stirling engine works by taking advantage of two basic physical properties of a gas. The first being that hot air rises, so as the air down the bottom of the aluminium can is heated up by the candle or flame, the hot air rises to the top where it is cooled down, and then the cool air sinks back down to the bottom to be heated back up again, and the cycle continues. A cooling jacket can also be added at the top of our system. It can be filled with water or some other form of coolant, and this helps to cool the air down faster than it would just with normal atmosphere cooling. This will allow our Stirling engine to pick up more revs, so if you want to make the engine go faster, try adding a water jacket at the top. The second property is that as the gas is heated up, it also expands. Now, the walls of the aluminium can won't exactly expand, however the elastic balloon will expand, and this is exactly what moves our Stirling engine along. As the air is heated up, the balloon is pushed upwards with the bolt on top, and this helps turn over the crankshaft of our Stirling engine. As the air is cooled, it shrinks back down and pulls the balloon back down with it. This also helps turn the Stirling engine over. The effect of the displacer is to help the air rise up and go back down again a lot faster than it would just done so. So altogether, as the displacer rises to the peak, the air is pushed back down to heat out, and the balloon is therefore pushed up, which helps turn over our engine. As the displacer is put down to the bottom, the air rises to the top and is cooled down, and this helps the elastic shrink and pull the crankcase down. This cycle continues, and this is what makes our Stirling engine turn over.
So that's the Stirling engine, guys. If you like this video, give it a thumbs up. If not, give it a thumbs down, but please leave a comment and let me know why. If you want to see more of these videos, hit that subscribe button. So until next time, take it easy.